Hello everybody, welcome back to our geography class. So in this video we are going to discuss again a very important topic from climatology, and the name of this topic is thunderstorms. So this thunderstorm is important for both optional student, those who have chosen geography as the optional, and for GS point of view also. So let us first focus on meaning and concept of thunderstorms. So what exactly this? Now when we talk about the thunderstorms, here one word which is mentioned about the thunderstorm is it is a tertiary atmospheric circulation. Now what is the meaning of this tertiary atmospheric circulation? We know that atmospheric circulation is the responsible for transformation of heat energy from surplus region of tropics to a deficit heat energy region, means polar area. So this is a mechanism through which heat energy is transferred from tropical areas toward the polar areas. So there are three type of atmospheric circulation. Primary circulation, example of primary circulation is global wind, trade wind, tropical, then we can say easterlies, westerlies wind. Secondary circulation example is seasonal wind, like monsoon is example of secondary circulation. And tertiary circulation is basically this type of atmospheric circulation depend on local factor, local conditions that depend on the topography of the area, that depend on the distribution of land and water, differential heating of land and water, that cause a atmospheric circulation that come under tertiary atmospheric circulation. Now a second important term which is mentioned about the is local storm. It is a local storm. It means something which is very local condition is responsible for formation of thunderstorms. Now according to A.N. Stroller defined thunderstorms. So what is the definition of thunderstorm? So a thunderstorm is an intense local storms associated with large dense cumulonimbus cloud. Now this is a cumulonimbus cloud is a keyword here, in which there are very strong updraft of air. Now when you will see the definition, you will find that 2-3 words are very important. 2-3 keywords are here. Now what exactly we know thunderstorm? It is a local storm. There is a cumulonimbus cloud, large dense cumulonimbus cloud, and in which very strong updraft of air. It means rising of air with very fast speed. So very vertical rising of air with a very fast speed. That is called strong updraft of air. Now this is a special case of convective mechanism. Special case of convective mechanism. Convection. It means these thunderstorms will only form during a daytime in a summer season when there is a insolation is very high, very intense. Ground surface gets heated. And the supply of warm and moist air. This supply of warm and moist air, that is called strong updraft of air, and that result in the formation of cumulonimbus cloud. And this is the shape of the cumulonimbus cloud. It is anvil shape, and cumulonimbus cloud is associated with your thunder and lightning. So it will be also cause a very intense downpour. The rainfall will be a very high, and this will be a very short duration. That's why sometimes this thunderstorms is also known as cloud burst. So basic here what happened, the supply of warm and moist air transfer latent heat of condensation, and that is the main mechanism that sustain the thunderstorms. And thunderstorms is different from cyclone. When suppose anyone ask you what is the difference between thunderstorm and cyclone, so cyclone, where you see the cyclone have a system of low pressure and isobar are more circular. In this case there is an updraft of the air. No isobar is circular here. So during a sunny day, summer season, very intense insolation, ground surface get heated, and there is a continuous supply of warm and moist air, which result in the formation of cumulonimbus cloud, and that associated with thunder and lightning, and this causes thunderstorms. In next we will talk about what are the conditions required for the development of thunderstorms. Now we will discuss here conditions for thunderstorm development. So first condition here is atmospheric instability. What is the meaning of this instability? It means that when a warm and moist air is continuously rising, it expands and further it rises, that will cause the instability, means formation of cloud, precipitation and condensation will be happen. These are the some cases with respect to the instability, and this is happened when normal lapse rate is more than adiabatic rate. This is very important to note it down. Normal lapse rate we know very well, like 6.5 degrees Celsius per 1000 meter, how a temperature decreases with increase in height, and adiabatic rate is basically how when air is rising, so expansion and contraction cause a change in heat. So in this case, as you see, air is that is rises, it will be expand in height, little bit in height, and other further expand. So normal lapse rate cause at the height of 4 kilometer 20 degrees Celsius, surrounding air temperature is 20 degrees Celsius, but the rising air temperature is 15 degrees Celsius. It means it is lower than the normal lapse rate, so it will further provide a buoyant force, and this air is further rises and it will further expand, so it will cause a instability. Okay, that is called atmospheric instability. So in this case, normal lapse rate must be greater than the adiabatic rate. Then third condition is warm, moist and rising on stable air. Okay, this is the most important condition, or we can say like a pre-requisite condition for the formation of thunderstorms. So warm and moist and rising on stable air must be there, so that it will be continuous supply of water vapor, so that it will be a cause for development of cumulonimbus cloud. Okay, as you see in the fourth case, enough supply of moisture from the ground surface. Now ground surface must have a supply of moisture. Air must be a moist, it will be a warm, so it will be continuous supply of moist air, and this will be cause a supply of latent heat of condensation. So see the focus number, see here the sixth number, enough supply of latent heat of condensation and fusion. Okay, so latent heat of condensation means how a basically vapor change in heat energy is released once air, warm and moist air is rises at some height, say 5 kilometers, 6 kilometers, it will expand, so its temperature will be decreases. So this is called adiabatic cooling. Okay, and this is also a release of heat energy. This is called latent heat of condensation. Air become cool, and this potential energy of the air change into kinetic energy, and this kinetic energy is the main responsible for provide strength to the storm. Okay, एंड फिफ्थ वन इज ग्रेटर थिकनेस ऑफ द क्यूमुलिनिम्बस क्लाउड. क्यूमुलिनिम्बस क्लाउड जितना थिकर होगा उतना इंटेंसिटी थंडरस्टॉर्म का स्ट्रॉन्गर होगा और उतना वो हैवी थंडरस्टॉर्म्स होगा. सो इट डिपेंड ऑन द कंटिन्यूअस सप्लाई ऑफ मॉइस्चर्स. देन अ सेवेंथ पॉइंट इज एफिशिएंट ट्रिगर इफेक्ट. व्हाट इज ट्रिगर मैकेनिज्म? ट्रिगर मैकेनिज्म मींस हाउ अ वार्म एंड मॉइस्ट एयर इज राइजिंग. मेन कंडीशन इज वार्म एंड मॉइस्ट एयर को राइज करना है, वो कैसे राइज कर रहा. सो देयर आर थ्री मैकेनिज्म थ्रू व्हिच एयर वार्म एंड मॉइस्ट एयर विल बी राइजेस. The first one is called insulational heating. Normal, when a ground surface get heated during a daytime, so warm and moist air rises because of insulation. Second one is called mountain barrier. Mountain barrier like orographic effect. If mountain is present, suppose in the path of the mountain is present and wind is now forcefully uplifted. Okay, so this is the mountain barrier. Then third one is called cyclonic front. Cyclonic front like when a cold air masses and warm air masses both come in contact with each other. So warm air mass is lighter one and it will be started to uplift. So in this case a rising of warm and moist air. So these are the three important trigger effect. Any of one will be responsible for the origin of thunderstorms. So like in most of the mountainous area you will see a cloud burst is happened. That is because of mountain barrier. That is when a warm and moist air hit the slope of the mountain, it continuously rises and then condensation and precipitation take place. That is also called a cloud burst. Okay, so these are some important conditions. So after the completion of what are the conditions required for the formation of thunderstorms, we will discuss here stages of thunderstorms. So like temperate cyclone that passes through 6 stages, thunderstorm is passes through 3 stages. Now the first stage is called a cumulus stage. As the name, this is the name of the cloud. So what type of cloud is called cumulus? The cloud having a flat base, dome shaped. Okay, this type of cloud is called cumulus, and this type of cloud is directly related with the convection process. So in the first stage, which is also known as youth stage, in this case ground surface gets heated. Okay, so warm and moist air come in contact with the ground surface, they also get heated and they started to rise and expand, and the result will be what happened? Adiabatic cooling. So this is called adiabatic lapse rate. Okay, so adiabatic lapse rate means the air is warm and moist air is cooling at the rate of 10 degree Celsius per 1000 meter, and because of normal lapse rate is more than adiabatic lapse rates, in this case a draft of the air will be a more higher and reaches a speed of 150 to 160 kilometer per hour. So this is the height 6 kilometer where a temperature remains 0 degrees Celsius, means above it whatever the moist air will be is in the solid form, that ice crystal. So in the cumulus stage, as you see, cumulus cloud is formed and updraft is only present. Now let's come to the second stage called mature stage. In mature stage, as you see, there is a complete formation of the cloud, and this cloud is called cumulonimbus cloud. Now in this case, you see there is a updraft of the air also. There is also downward movement of the air, means updraft and downdraft both will be seen in second stage and mature stage. So cumulonimbus cloud is more associated with thunder and lightning. So in mature stage, a complete thunderstorms, we can say mature thunderstorm will form, where you will see a very heavy rainfall. Okay, lightning will be here, thunder and lightning will be here, cumulonimbus cloud will be there. There is a rising of air with a very high speed, and also with the same speed there is a downward movement of the air. So this will be the second stage. Okay, third stage, where you see only a downward movement of the air, there is no updraft. So if no updraft, it means there will be a no rising of warm and moist air. So when no rising of warm and moist air, it means it will be cause stability of the atmosphere. No cloud formation, no further cloud formation will be, no supply of latent heat of condensation. So whatever the energy that make thunderstorm more strengthening, that will be completely lost because of not supply of warm and moist air is completely cut off. So in this case, cumulonimbus cloud will be not here. Alto stratus and cirro stratus cloud will be, as this both the cloud is a rainless cloud, and this downward movement of air cause will be spread over the ground surface, and this will not allow the further movement of the air. So no rising of air, and that will cause a stability in the atmosphere, and complete all the energy that strengthen or sustain the movement of thunderstorm is completely energy, all the energy is completely finished. So this is the called dissipating stage and senile stage. So this is how a thunderstorm passes through a cumulus stage, mature stage and dissipating or senile stage. Okay.